Hi everyone, I am João Souza, and this is my final year project for my Mechatronics degree at ATU Sligo. Today I will show you how I built a smart water tank system using Arduino control. It's designed to manage water level automatically, just like in real industrial systems inside many industries, but with affordable parts. So why does this matter? Well, in industry, automation saves time, money, and resource. My goal was simple: use basic components like Arduino but add advanced logic to control water levels precisely. So let's dive in. So here what the system does. Keep the water level in tank TA101 perfectly balanced. Use a pump P101 and valve XV102 to refill the tank. Tracks water flow with sensors and display everything on LCD screen. Of course, all automated. Here's how it works. Water starts in tank 102, flows through the hand valve, the solenoid valve, through the pump, the flow indicators inside the tank 101. The water level is monitored by this sensor. Pass inside the hand valve, solenoid valve, again in one flow indicator, pump, and goes to the process. We can divide the system in inlet. So this is the inlet part, and this is the outlet. Basically, we have two controls. This is composed by the solenoid valve, the pump, and the flow meter. In the other side, we have the same solenoid valve, flow meter, and the pump. This solenoid here is controlled by the operator. And this solenoid and pump is controlled by the system. It's automatically. The system follows simple rules. The ultrasonic sensor checks the water level. If the level drops too low, the valve opens and after 2 seconds the pump starts refilling. So if the level is below, for example, 30%, which is the set point, the solenoid valve XV102 will open. And then after 2 seconds, the pump 102 will start and the PWM is proportional. So we start in 105 and then we raise until 255 and then when it get closer to 60%, which is the maximum set point, close again to 185. When the tank 101 reach the set point max, the solenoid valve on inlet will close and the pump will stop. The flow meters will measure the flow into the tank 101, which is the main tank. Another rule is the XV101, which is controlled by the operator, just can't be opened when the tank level is above 20%. And on serial on Arduino, we can commands open and close. We will open and close the XV101. So here's the components used. First is Arduino. It acts as the main controller that runs the control algorithm and manages all inputs and outputs. It's where the code is written and executed to control the logic of the system. The second component is HCSR04, ultrasonic sensor. So this is the LT101. Measure the tank level in TA101 using ultrasonic sound waves. So basically it sends out a sound pulse and calculates the time until the echo returns, converting that into distance. You must calibrate the sensor. Imagine you have your tank here, which is 25 liters in total. Have your sensor, ultrasonic sensor here, and the distance total will be, for example, 40 centimeters. Measure, for example, 5 liters and pour here. And then you find the distance. 40 centimeters will be 25 liters. And when it's distance here, x, will be 5 liters. Solenoid valves. So these are electrically controlled valves that open and close based on commands from the Arduino. So basically there is a coil here, and when this coil is energized, it will lift a plunger, allowing the water flow here. Relay module. So this allows the Arduino to safely switch higher voltage device like solenoid valves using a low voltage digital signal. So there is an advantage to use a relay module because it electrically isolates the control side from the low side. This is how we wire it. So imagine we have here positive and negative side, and then power supply, which will be 12 volts, plus and minus. So we'll be connected to the power source. The plus will be connected to here, which we're gonna use the normally open side of relay, and then this will be linked to positive. This ground will be connected to Arduino, and here will be the control signal, digital 5. The next component used is the flow meter. So it measures the rate of water flow entering and exiting the tank. We calibrated them by comparing sensor readings to a real volume collected during a timed flow test. There is a magnet here in every end. The water will pass by and the turbine will spin. Every time those magnets pass on the sensor, we'll send a signal to Arduino. So another test could be allow the pump to run for 10 seconds. Measure how much water passed by the sensor on a jug. Use a scale. And for example, you have 500 milliliters. You had 200 pulse. So your calibration factor will be total pulse will be 200 divided by actual volume, which you measure with a scale, so it will be 500. So I know in every 400 pulse will be 1 liter. L298N is the PWM motor driver. Control the pump speed using PWM, pulse width modulation. PWM simulates analog voltage by sending rapid digital pulse or varying with it, controlling motor speed. So by adjusting the PWM duty cycle, you can precisely control the pump speed, allowing efficient flow regulation. varying the voltage, you can control the speed. Here 12 volts, and the minimum will be 9 in my case, because PWM 255 was equivalent of 12 volts, and 185 9 volts, which was the minimum for my system. Because for this pump, this DC pump, if the PWM was below 185, less than 9 volts, the pump would not start. In my case, 255 and then 185 PWM. So the voltage will be vary here, and then the speed will be differently, and then you can control the flow. We have the power supply here, 12 volts, and the Arduino. So this is the ground, and the ground must be shared between the power supply and the Arduino. Here's the 12 volts. This is the control pins. So you have the enable, in this case enable A, and in will be connected to the Arduino, for example in digital 5, and then it will control the pump speed. The main overview, my control panel, the reservatory, which is TA102, the solenoid valve controlled automatically, the pump, and the flow meter. So this is the inlet of main tank, which is TA101. This is ultrasonic sensor, which measures the level of the tank. The tank capacity is 25 liters. So this is the outlet controlled by the operator, solenoid valve, and pump, 12 volt pump. So the water goes to the process, but in reality goes back to a reservatory. And this is the control panel, which is composed by circuit breakers, power supplies for Arduino, pumps, and the relays. So I created a wire diagram, which helped me to assemble everything. The driver, which controls the speed of the pump. 2-channel relays as well, controlling the main solenoid valves. And the flow meters. So the system will be on with the command the system on, and then if less than 30%, we start to fill. The PWM is getting high, started in 185, so the set point is 60%, so we stop at 60%. Stops automatically. When you write the command open, if the level is less than 20%, the pump will not start. If the level is more than 20%, you can open the solenoid valve. When it's less than 20%, is a safety measure. The pump will not start and the solenoid valve controlled by the operator will close automatically as well. If it's more than 20%, you can open and close the XV101, the outlet valve. If it's less than 20, it will stop automatically. We'll raise until it gets to the maximum set point, which is 60%.